the difference in elevation between the diversion spillway and the environmental flow spillway. Now, my next problem, from a technical point of view, is to estimate these two differences in elevation. Is the problem clear, or are there any questions? It is very, it's very intuitive, it's very easy to understand, but on the other hand, the first time you need to put some thought on it, and you need to understand what is the priority. The first priority is the environmental flow. The second priority is to divert the design flow. The third priority is to make sure that you have the flow of high flows downstream. Keep in mind that in some administrations don't allow you to put any gate on the environmental flow spillway, because they want to make sure that nobody can close it. Because it's clear that water users have an interest in maximizing the withdrawal and minimizing the environmental flow. On the other hand, if you talk to fishermen, they have an interest in maximizing the environmental flow. And therefore, there are competing interests which lead to animated discussions. And if you put a gate there, somebody could go there and run over the gate without any permission. And therefore, some administrations just prescribe that there is no gate. And some administration also suggest that the width of the environmental flow spillway is at least 40 centimeters in order big fishes to pass through. So there are some indications about the shape of the environmental flow spillway given by administrations, and also indications about the presence or not of the fish ramp. And you have to look for the local prescriptions, local obligations, local laws. And if you look within a country, there might be changes depending on the administrative region. So if you look at Italy, there are changes in the Emilia-Romagna region with respect to Tuscany, with respect to other regions that are more restrictive with respect to others. And also, the regional laws and national laws tell you how to compute the environmental flow. The computation depends on the catchment behaviors, on the behaviors of the river, on the behavior of the fishes, etc. And you have to make sure that you refer to the correct law, because it's not your decision. Estimating the environmental flow is dictated by laws in general. In Italy for sure, but I would say that in any country. So it's not your decision. It's your decision instead to estimate these differences in elevations. And this is our next problem. When instead you move to the diversion spillway, you see gates there, and these symbols identify gates. It's clear to all of you what is a gate. A gate is a device that allows you to close a spillway. And the reason why we want to put gate here is, as I mentioned to you before, for allowing cleaning, maintenance, etc. And also keep in mind that in some cases it's advisable, if you have a river with strong sediment transport, it's advisable that you close the diversion during high flows, because during high flows you have more bed load, more sediments transported by water, and therefore you may not want to take that water. Whatever the use is, you may not want to get that water. Okay, now, how can we estimate these differences in elevation? Clearly, what we want is that before beginning the diversion of water, we have environmental flow flowing through this spillway. Clearly, if you put the diversion level too low, at a level that is not elevated enough, you start the diversion before the environmental flow is, the full environmental flow is released. So you don't want to make this delta H1 too small. This delta H2 too small. On the other hand, if you increase it too much, you start the diversion too late, which means that you are losing some water through the environmental flow spillway, which is not lost. It's an increase of the environmental flow. But in any case, you don't want to release from the environmental flow spillway more water with respect to the environmental flow. And therefore, you have to determine delta H2 by computing, through an appropriate relationship, the amount of flow that flows through the environmental flow spillway in the presence of a water head that is equivalent to the level of the environmental flow spillway plus delta H2. Okay? And we have a relationship that is suggested by hydraulics for computing the flow through a spillway. The same relationship will be used to determine delta H1. So let me show you the relationship. This is our relationship for delta H2. Let's look at it, and we close our lecture today by looking at this relationship. So, first of all, we want to make sure that through the environmental flow spillway we have the flow of the environmental flow, which we call with the symbol Q dmV. dmV is given by the fact that the environmental flow in Italian is called the flusso minimo vitale, and therefore dmV is the acronym that is used in Italy to identify the environmental flow. So this is the environmental flow, which flows through the environmental flow spillway. It is given by a coefficient called mu, and this is a weir coefficient. For a weir with a large threshold, mu is equal to 0.385. If you have a weir with a sharp threshold, then you have to change the coefficient. But given that here typically we have weirs with large threshold because they have to bypass thick structures, then we use for mu 0.385. LC is the width of the environmental flow spillway. Of course, the larger the spillway, the larger the flow. Delta H2 is the water head, the water height over the spillway, which is precisely equivalent to the difference in elevation, delta H2, between the two spillways, environmental flow and diversion. Because we want this water height to be equivalent to delta H2 in the presence of environmental flow over the spillway. And then you have a square root of 2g, g is gravity, times again delta H2. And therefore you can, if you want, rewrite this relationship as me LC delta H2 to the power of 1.5, and 2g to the power of 4.5. From this relationship, you can get an explicit relationship for delta H2 by fixing the environmental flow QdmV, which is given by ρ. Okay. A similar relationship will be used for computing delta H1, but instead of the environmental flow on the left-hand side, we will put the design flow, which is the flow to be diverted. Okay, for now, for today, we stop here. One thing I wanted to tell you, I would like to reiterate my invitation. If you want to deliver a presentation to the audience on something that is related to what I'm teaching, or something that you believe for whatever reason is interesting to the class, I really would like that you take this opportunity. We have some time left because we have the full month of May, and therefore I just wanted to invite you to take this opportunity once again. Second thing that I wanted to tell you, next week I would like to discuss with you again if you would like to anticipate the closure of the course by identifying additional days of lectures. Maybe that some colleagues now are finishing to deliver their lectures, maybe that we can find some time. If we cannot, it's not a problem. I mean, we can close at the end of May, beginning of June as officially planned. Thank you.